Okay, hi everyone, welcome to another video. Now, last video, we started looking at using Pythagoras' theorem to find the hypotenuse, to find the longest side of our right angle triangle. Now, in this video, we're going to use this same theorem to find one of the shorter sides. And the way we initially lay out the question is very similar. And you may remember, we always ended up with an equation. So once we plug in all the necessary information, all the information we're given from questions, we can start to think about solving the equation. And when we look for shorter sides, this takes an extra step, but it's not too bad. Hopefully, it's not too intimidating. We can just work through it in the same way by just thinking of solving an equation. Now, I'm going to give you a few questions today, two regular questions and one worded question, and we're going to see how we go. So my first question, I'm looking at a side A, a side 24, and a side 25. Okay, so that's a shocking triangle. I'm just looking at that now. That's all right. Let's jump straight in. So the very first thing I'm going to do, what I've done for all of these questions, is I'm going to write out Pythagoras' theorem. Firstly, it's the best way that you can start to think about remembering it. And it also helps you with making sure you're substituting your numbers into the right place. So I have my theorem. Now I want to start identifying which side is which. So I have an unknown side here, and I have a length of 25. Now this thing is my hypotenuse. This is my longest side. Why is that my longest side? Because it opposes my right angle in my triangle, because that's the biggest angle in this triangle. You can actually kind of see that. We have an acute angle here, we have an acute angle here. A 90-degree angle is bigger than both of those. So where's my 25 going to go? Well, this thing here, it's my hypotenuse, so I can think of this as side C. This is my longest side. So I'm no longer substituting that into one of these. I'm putting that over here. And my 24, I can make that B. That's another shorter side. So I can put that either in A or B, but since I have A as the pronumeral in my question, let's substitute it into where B lies. So in laying out my working out, I'm going to say A squared plus, let's substitute 24 in for the B. I get 24 squared equals my longest side, 25 squared. So you can see, compared to the other video, we may need a little bit of extra work here. We need to rearrange this equation to get an answer, because the unknown, with any equation that we want to solve, the unknown has to be on its own on one side. And we want all the other numbers, all the other pieces of information on the other side of the equals sign here. So let me first just write out what each of these square numbers equal. I have A squared plus 24 squared is like saying 24 times 24. That gives me 576. And 25 squared, 25 times 25, gives me 625. Now that I'm here, well, I'm saying we're going to put on our equation hats here, and I have A squared, some number, plus 576. So when 576 is added to this number, I get 625. Now, 625 is 576 more than A squared. So I can do what I've been doing with my equations so far. I can do the opposite. To find A squared before 576 was added, I'm going to subtract that from both sides. And what do I wind up with? Well, I get a squared on its own now, because 576 minus 576 cancels out. So I get 0 or a squared on its own. And that equals, on my right-hand side, 49 when I subtract 576 from 625. And now it becomes the same thing that we had in the previous video, or the same type of looking equation. And you can see it was one extra step because we wanted to do this subtraction down here. But once I get here, I can just take the square root of both sides. So taking the square root of a squared gives me a, it undoes the squaring, and I'm taking the square root of 49. Now you may remember from the previous video, square rooting a perfect square gives you a positive and a negative number. So here, the square root of 49, the number that times by itself to give me 49 is 7 or negative 7. But remember here, we're looking at measurement. So let me put some units here. We are looking at a length measurement, which means we're going to have something positive. We're not going to have negative 7 millimeters here. We're using a positive length. So that at the end just gives me 7 millimeters as my answer. Now, we'll try one more regular question, and then we'll try a worded question at the end. So here I have question 2. I'm going to try to find b, and my hypotenuse is 5, and my other side is 4. Sorry guys, just a quick sense check. I totally forgot to mention this. We're finding a length of one of the smaller sides here. And that's the answer I got in my previous question. So I want to just make sure that what I got makes sense in the context of the question. So this is one of the smaller sides. So this we expect should be smaller than the hypotenuse, because the hypotenuse is the longest side. And indeed it is. If we got something bigger than 25 millimeters, we've done something wrong. And then we need to go back and reevaluate, look back at our working. Maybe we've done something wrong. Maybe we've put something wrong in our calculators, but we can go back to this idea. In the last video, we said, well, if we're finding a hypotenuse, it has to be the longest side. Now here, because we're finding one of the smaller sides, the answer we get, we'd expect it to be smaller than the hypotenuse. So let's think about that in the context of this question as well. Now, my b is a smaller side here. I have, let's put some units as well. 5 meters, 4 meters, b meters. My 5 meters here is my longest side. Why? Because it's opposite my right angle. This is going to be my hypotenuse. So the length I get for B can't exceed 5 meters. If it's bigger than 5 meters, I've done something wrong, because 5 meters by definition, this being the hypotenuse, has to be the longest length of my right angled triangle. So let's have a look at how we could go about this question. Once again, I'm going to write out Pythagoras' theorem. I want you guys to be getting sick of writing this. That's kind of where we're at. I know it's going to be really annoying doing this every time, but this is a way for you to A, just remember it, retain the information we're learning, but to also have it in the back of your head that you can check. You have a nicely laid out equation and you can check if you've substituted in the right values from my measurement here. Okay, now let's put my 4 meters. We'll put that in place of A because it's one of the smaller sides. So I have 4 squared plus B squared equals And my 5 meters has to go in place of the c squared. Why? Because my c is my hypotenuse. It's my longest side length. Whoops. So that's c here. When we label our right angle triangles A, B, and C, C is always the hypotenuse. So this 5, I'm going to pop on the right-hand side here, 5 squared. Okay, now that I have this, let's just fill in these values. 4 squared is 16. B squared, well, B is what I'm solving for, so I'm leaving this, equals 25. So now I want to solve for my side B. I want to rearrange my equation. And in a similar way to the last question, 16 is added to b squared to give me 25. So b squared must be 16 less than 25. And we show this from solving equations by doing the opposite operation. Here we're adding 16. So we want to minus 16 to undo this. And that's going to kill this term here, gives me 0. And I'm going to get left with b squared on the left-hand side. 25 minus 16 gives me 9. So taking the square root is the next thing I want to do, because I have that b squared equals 9. So I can undo the squaring by taking the square root of both sides. And that leaves me with b here, because I'm undoing the squaring, and b equals the square root of 9. Now, what number multiplies by itself to give me 9? Well, it's 3. Now, technically, we're also going to get 3 and negative 3, because this is a simple quadratic equation, like the one we've talked about in solving equations. But once again, guys, we're looking at measurements. I have these lengths in meters. We can't have negative 3 meters if I were measuring something with a tape measure or a length. So what I want to do here is just take my positive answer, 3 meters. Now let's do one more question to get you used to some worded questions and how we can chip away at dealing with worded questions, getting the most important bits out and working from there. So we have a 10-meter steel brace, holds up a concrete wall, So the bottom of the brace is 5 meters from the base of the wall. Base of the wall. Find the height of the wall correct to 2 decimal places. So I'm just going to write this just to save time. Find height of wall. Okay. Now, and we'll round this answer to 2 decimal places. Now, what I want to do here with worded questions, these scare a lot of students, and probably rightly so. They can be a bit overwhelming, especially because we're doing a lot of reading in maths. We might not be used to that. Now, here, we want to just take all the important bits of information from the question. So a 10-meter steel brace is leaning up on a concrete wall to hold it up. So it leans up a concrete wall, which is going directly up from the ground. So the bottom of the brace is 5 meters from the base of the wall. And we want to find the height of the wall. Now, if you ever encounter these types of pictures, I'm going to always say this: draw a picture, because drawing a picture really helps you visualize what's going on. So I have my wall. It's like a brick wall. And I should have probably, let me draw this a little straighter, just so you guys can see what I'm about to do. I have a brick wall, and I need to find the height of the wall. So I'm going to mark that as H, and a steel brace is holding up that wall. And it's holding this up. It's going to go here, and it goes down to 5 meters from the base of the wall. So it's leaning up against this wall, holding it up, and it's 10 meters long. And my ground here is there, and the base of the wall to the bottom of my steel rod, what was it? No, steel brace is 5 meters. So here to here. Now, applying Pythagoras' theorem, guys, is all about putting triangles into the real world. We're constructing these kind of imaginary triangles. We're looking to build these in everyday situations. And if you were to actually do this, if you were to rest a steel brace, some kind of beam, on a wall, on a vertical wall, it's going to lean like this, and then the ground along with that wall is going to make a triangle. Now, we're looking at a wall, right? A wall that's going perfectly straight up. What angle does that wall make with the horizontal ground? Well, it makes a 90-degree angle, right? If we just trace it out, this looks like a perpendicular angle relationship. So I can draw in a right angle here, and now I can apply Pythagoras' theorem. Now let me move this over to the side just a tad bit. Go here. And I'm going to write Pythagoras' theorem once again because I don't want to get confused and I want to learn this and remember it as quickly as possible. I have my big Pythagoras' theorem up here. This is my bread and butter. Now I just want to substitute in the values here from my question. And look, we've translated the question perfectly into a drawing. We have a 10-meter brace. We have that it's 5 meters from the base of the wall. You can see here, 5 meters from the base, the bottom of the wall. And I've drawn my wall to which I want to find an unknown height of h. Now, once I have this, I can substitute in the values that I'm given from the question. So, first of all, what's my hypotenuse? What's my longest side? Well, it's the one that's opposite to my right angle. So 10 meters, or the longest side, is my hypotenuse. And that we can think of as my length C. So that's going in here. So I'm going to put that in straight away. In the place of C, I'm going to put 10. So I get 10 squared on the right-hand side. And I'm just going to let my H be A, for example. Doesn't really matter. But this A, B, and C are just sides of my triangle. You don't have to think like, oh, because I have a H and not an A, I can't solve this. These letters in Pythagoras' theorem are just a placeholder to show the smaller sides and the hypotenuse as C. So I can put my H for either A or B. I'm going to put it as A so that I have H squared plus my next smaller side is 5. So I'm going to substitute 5 in place of B. So I get 5 squared. Now, once again, I want to leave my H squared and I want to find what 5 squared is. 5 times 5 gives me 25. 10 squared, 10 times 10 gives me 100. Now, H squared, I had 25 added to that and that gave me 100. So H squared must be 25 less than 100. Should be the difference between 25 and 100. So And this is all just a recap of what we've been doing in equations. If any of this is new to you, please go back and watch those videos. They'll explain it in longer time and with more detail. But here I'm just assuming we know how to solve equations. Now, equations are our building blocks here. So now we can just do 100 minus 25 because my left-hand side only has h squared on it. And on my right-hand side, I get 75. So therefore, my h is going to be, I want to take the square root of both sides. The square root undoes my squaring of h to give me what h is, to give me the number that times by itself to give me h squared. And taking the square root of 75, you can see 75 is not a perfect square. So my answer is going to be to some kind of decimal places. And the question asks for 2 decimal places. So when I pop that into a calculator, I get approximately 8.66 meters to 2 decimal places. Now, this symbol I've used here just means approximately in maths. It's not exactly equal to, it's approximately equal to 88.66 meters. Now, really quickly, let's do a sense check. So, does my answer make sense? Well, 8.66, we would expect it, the only thing we know about it is that we'd expect it to be something less than my hypotenuse, something less than 10 meters, and 8.66 is smaller than 10. So the thing I found for my height is correct. It makes sense within the context of the question. It's never going to be something more than 10. So my answer of 8.66 is correct. And that's how we can apply Pythagoras' theorem to solving both regular questions, like we saw in the first two, as well as a worded application question. But thank you so much for watching, guys, and I'll see you in the next video.